Welcome to day 25 of our series. Today we are going to explore an interesting and clever trick, swapping two numbers without using a temporary variable, using the bitwise XOR operation. It's a neat little technique that's often used in low-level programming. Let's begin by looking at the traditional method for swapping two numbers. Usually we use a temporary variable to store one value while we swap the two. In this example, we will store the value of a in a temporary variable, then assign the value of b to a, and finally assign the value of the temporary variable to b. This method uses 3 lines of code and an extra memory location for the temporary variable. Now let's introduce the XOR method, which swaps two numbers without using a temporary variable. Here's the trick. We perform three XOR operations between the two numbers. First, we assign A assigned A XOR B. Then we perform B assigned A XOR B. And finally, we assign A assigned A XOR B. This may look complicated, but as we go through the steps, we will see how this works without the need for extra memory. Let's go through an example to see how the XOR swap works in practice. Suppose A assigned 5, which in binary is 0101, and B assigned 9, which is 1001. First we perform A assigned A XOR B, which gives us 1100, which is 12 in decimal. Next we perform B assigned A XOR B, which gives us 0101, which is 5 in decimal. Finally we perform A assigned A XOR B, which gives us 1001, which is 9 in decimal. As a result, A and B are swapped. A is equals to 9 and B is equals to 5, all without needing a temporary variable. Why does XOR work so well for swapping? The answer lies in the properties of the XOR operation. XOR has some interesting properties. A XOR A equals to 0, A XOR 0 equals to A, A XOR B XOR A equals to B. Because of these properties, XOR is reversible, meaning we can undo the operation, which is crucial for swapping values effectively. Although XOR swap is a clever trick, there are a few things to keep in mind. First, we should never try to swap a variable with itself, as that will just result in 0. XOR also works only with integers, so don't try this with floating point numbers. In some cases, using a temporary variable might actually be clearer and easier to understand than using XOR. Lastly, modern compilers optimize swapping operations, so the benefit of using XOR in most cases is minimal. Here's a complete example in C++ showing how the XOR swap works. We first initialize two integers a and b with values 5 and 6. Then we perform the three XOR operations to swap the values. After running this code, we will see that a becomes 9 and b becomes 5. It's short, efficient, and works well with integers. Here's a fun fact. The XOR swap trick has been popular in embedded systems and low-level programming, where memory is often scarce. It's a clever solution to a simple problem, and it also makes for a great interview question. So the next time you need to swap values, you might want to impress someone with your XOR knowledge. Now let's test your understanding with a quick quiz. Suppose A is equals to 12 and B is equals to 10. Can you figure out what happens if we perform A XOR B?